Okay, once more we're looking at the function y of t equals 0.00226 t squared minus 4.3 plus 92. We note that the vertex lies on the axis of symmetry, which lies at t equals 951, as we just found from the quadratic formula, and that the zeros are 951 plus and minus 930, which gives us 1881 and 21 for the location of the zeros. Plugging t equals 951 in for t in the function, we find that y of 951 gives us negative 1953. That's the location of the vertex. So we see that the graph goes down below the x-axis and back up through, down to this vertex at 951, negative 1953. The y-intercept is going to occur, of course, when t equals 0. T goes this way, t is 0 here, and t is 0 at the point where the graph meets the y-intercept. If we were to estimate the height of this thing from the graph, we would probably estimate that this is around 1,000, because this distance down here is 1953. This isn't quite as far, but it looks like 1,000 or a little more. And that's not what we're going to get. Remember that this 21 here is a little bit out of scale. It should be much, much closer to the t-axis than it is, so that when we sketch the parabola, we're not getting a really accurate depiction of where the y-intercept is. In any case, if we plug in y equals 0, we clearly get 0 from this term, 0 from this term. Plug in t equals 0, I'm sorry. We get 0 for this term because t is 0, 0 for this term because we're multiplying again by t that's equal to 0, and we get 92 for the y-intercept. Okay, that's not like the 1,000 that we would estimate, but remember again, the graph isn't real reliable. Okay? Now, we can use function notation here. We can say y of 1881 is 0. That is, if we plug 1881 in here, we're going to get 0. We don't get exactly 0, but to round off error, we do. Okay, and if we plug 21 in here, again to a round off error, we get 0. Y of 951, this is how we get the vertex. We plug 951, substitute it for t, so that it substitutes for t throughout the expression. And here's the arithmetic. Very easy to follow. And we end up with our negative 1953. So we've used function notation, substituting each of these numbers for t in the definition of the function to make each of these statements.